Section 2.1, Relations and Functions. The objective for today is to graph relations and identify functions. A relation is a set of pairs of input and output values. There are 4 different ways to represent relations. 1, ordered pairs. 2, mapping diagram. 3, a table of values. And 4, graph. We're going to work on each one of those so you know how to do each one when they're asked for. Problem 1. When skydivers jump out of an airplane, they experience free fall. The photos on page 61 show the various heights of a skydiver at different times during a free fall, ignoring air resistance. How can you represent this relation in 4 different ways? So first of all, that should have been show. Okay. So looking at page 61, we're going to do each one of these. All right, ordered pairs. So when you're looking at the picture, we have 0, 10,000. We have 4 seconds, 9,744. And then we have 8 seconds, 12 seconds, 16 seconds. At 8, it's 8,976. At 12, it is 7696. And at 16 seconds, it is 5904. So basically, I took those ordered pairs from the picture. The one that was listed first was the X. The one that was listed second was the Y. The next thing we want to do is a mapping diagram. Now, when you're looking at a mapping diagram, the values in the left circle need to increase. So in the left circle are going to be the X values or the input. So we're going to go 0, 4, 8, 12, 16. The output is going to be the values that go with them. 10,000, 9744, 8976, 7696, and 5904. Each one of these then gets an arrow going to which number was listed. Let's go to a table of values. The X value stands for time. The Y value stands for height in feet. So all I'm doing is putting them back in a table. Like that. Make sure when you're doing a table of values, if it is something that is very descriptive in the problem, make sure you label each column with what it stands for, not just X and Y. And then we'll put it on a graph. Now use graph paper, don't just hand draw it like this one. Since the numbers, the height starts at 5904, I'm going to put a break in the graph and we're going to go with 5,000 and go up by 1,000s. Okay, now we'll go with the time. So on the side, it's height in feet. For the x's, it is time in seconds. So if we go by twos, and you could keep going if you want to. So at 0, it's up here at 10,000. At 4, it is at 97. Oops, 10,000, I did 11, just a minute. At 4, it's just under 10,000. And here you have 1,000 per square, so they're going to be kind of clumped together a little bit. At 8, it's just under 9,000. At 12, it's just under 8,000. And then at 16, it's just under 6,000. And then when we're doing this, we do not want to connect the dots. And then make sure each side, x and y, are equal increments. The domain of a relation is the set of inputs, or x-coordinates of the ordered pairs. The range is the set of outputs, or y-coordinates of the ordered pairs. Problem 2, use the relation from problem 1. What are the domain and range of the relation? So again, the domain are the x elements. And we're now on page 62 if you're following along in your book. The ordered pairs were again 0, 10,000. So the first element of my domain is 0 because that's the x value. The next element of the domain is the next. Whoops, I don't know what that is. Okay. The next element would be 4. And we're only looking at the x's here. Then we go to 8. Then we go to 12. Then we go to 16. The range elements would be those elements of the y's. 10,000. 9744, 8976, 7696, and 5904. Got it. Question number 2. What are the domain and range elements of this relation? You can pause, try it on your own, and come back and check to see if you got it. So domain would be those elements of the x's. So the domains are the x elements. So -3, 0, 2, 9, and 23. And the range elements would be those that I'm doing pink. 14. Make sure these go from small to large. And the y elements again. So with this one, the smallest one looks like it's -99. And they go in reverse order. -18. Then it's going to be 0, 7, and 14. So make sure those elements are small to large. Problem number 3. Is the relation a function? So -3 gets paired up with -2, 0 gets paired with 7, and 4 gets paired with 1. So we're going to say yes, each domain element is paired with one range element. Okay, let's look at some ordered pairs. We have 4. I'm only looking at the x's first. Okay, and what I notice is that 4 is listed twice. So the two that I'm really focusing on are these two. Now, each x coordinate can only be paired with one y element or one range element. And when you're looking at this one, 4 gets paired with -1 and 4 gets paired with 1, which means this is not a function. The only way it would be is if the two ordered pairs 4, -1 would be both 4, -1 or both 4, 1. If they're both the same, when you graph it on graph paper, it would be one location, not two different points. So this one is no, because 4 is mapped to two different things. 4 is mapped to two different range elements. Another example that can tell you if it's a function or not is the vertical line test, or VLT. If a vertical line passes through more than one point on the graph, then it's not a function. Some people call this the pencil test. If you actually hold your pencil vertically on your paper and drag it from left to right, if it hits 2 points at the same time, and of course, here's what I'm talking about, are these 2 points right here. It's hitting 2 points at the same time. This is not a function. Okay. Oh, that one got drug here. My circle, not sure where that came from, but okay. So use the vertical line test. Which graphs represent functions? All right, so part A is going to be no, because if you look at these 2 points vertically at the same time, I'm going to say no. If you do a vertical line test and drag it from left to right, here it only hits 1 point at a time. I'm going to say yes on part B. On C, if you look at these points right here, they are vertical from each other, so I'm going to say no. A function rule, an equation that represents an output value in terms of an input value. So a function looks kind of more like an equation. The only difference, oops, zapped out of here. The only difference is on this one, they have this notation right here that is read f of x. So instead of saying y equals 2x plus 1, it is f of x equals 2x plus 1. So function notation looks like an equation with a y equals, except it has a variable and an x value. So f of x, it means the function is in terms of x, and it just looks like an equation. Independent variable represents the input of the function. In the example above, the input are where you plug the numbers into, which are the independent variables. The dependent variable depends on the independent variables that are picked. So the dependent variable represents the output. So if you can look at an equation and know what the input is versus the input is the independent variable, the output is the dependent variable. So for f of x equals negative 2x plus 5, what is the output for the inputs negative 3, 0, and 1/4? So if you want to do this in a little table format, input, output. The output is f of x, the input is x. So negative 3, 0, and 1/4. So what we're going to do is we're going to substitute each of these numbers into our equation or our function. So negative 2 times negative 3 plus 5. That would be 6 plus 5 or 11. Negative 2 times 0 plus 5. That would be 0 plus 5 or 5. And negative 2 times 1/4 plus 5. So negative 2/4 would be negative half plus 5, you get 4.5. So that's the output for the inputs that are given. To model a real world example, identify the dependent and independent variables. For instance, distance is a function of time, means that distance depends on time. So distance would be the independent variable, and time would be the dependent variable. Problem number 6. Tickets to a concert are available online for $35 each, plus a handling fee of $2.50. The total cost is a function of the number of tickets bought. What function rule models the cost of the concert tickets? Evaluate the function for 4 tickets. So the thing we want to do first is write a function, then we want to evaluate for 4 tickets. Okay, so we'll do cost is C. T for tickets. So make sure you define your variables quickly. So total cost. It's a function notation, so cost of T tickets. It's going to be $35 for every ticket. So we need a T with that. 1 ticket would be $35, 2 tickets would be $70, and so on, plus a handling fee of $2.50 for each one. So there's my function. They want us to evaluate this at 4. So what we do is we plug a 4 into the T in both sides. So this would be 35 times 4 plus $2.50. So the cost of 4 tickets would be 35 times 4 plus $2.50, $142.50. Now the thing with functions is you do not want to do anything with this side. That tells me that in this equation or this function, we substituted a 4 in for the x, and the answer is 142.50. So it tells you what you put in. It also tells you what you got for an answer. We'll go through some more examples tomorrow, just in case you're confused on something. Bring questions, please.